Hello. Today I want to talk about applying the chain rule to some functions that don't seem to need the chain rule, but students commonly mistake as not needing the chain rule. So let me remind you again that the chain rule is d dx of f, the derivative of the composite of two functions is equal to f prime of g of x times g prime of x. Now what I mean is a student looks at a function and determines no chain rule is necessary. The first example I have is h of x equals the square root of 2x. Now, at its face, it looks like there's no chain rule necessary here. And there isn't if you know the distributing of the square roots. But what you should notice is a chain rule should be used to this particular problem. So again, this is a composite of two functions, f of g of x. Again, I know that you can distribute the square root to each one of the terms. It's just this does also work if you apply a chain rule to it. So, for example, if I were to let f of x, that's going to equal the square root of x. And my g of x is what's inside, which is going to be 2x. So, again, I need f prime and g prime of x. So, f prime of x, again, I need to turn this into a power form. So that's f prime of x to the 1/2, which equals 1/2 x to the negative 1/2. And the derivative of g of x, which is, even though it's very simple, is g prime of x is just 2. So the derivative of h prime of x, equals f prime of g of x times g prime of x. Well, f prime of g of x, we know g of x is 2x. So I'm going to say f prime of 2x times the derivative of g. We denoted 2x as being g because it's inside. The derivative of g is just 2. So this is going to be times 2. So now we want to rewrite this factor here. This is f prime of 2x. And since f prime equals 1/2 x to the negative 1/2, I will replace all the x's with 2x. So finally, we get 1/2 2x to the negative 1/2 times 2. Again, this is not in its simplest form. You can see that the 2's cancel out. But please do not cancel these 2's. Those 2's cannot cancel out because it's in the square root. And it's also in the negative exponent. So if I wanted to, this can be rewritten. So these would go away. This would be rewritten as 1 over parentheses 2x to the 1/2. Again, it's very important that you put the grouping symbols around both the 2 and the x, because both of them are having the square root applied to them. So in the radical notation, this would be 1 over the square root of 2x. Okay, so that is one case where a chain rule can be applied, but may not automatically jump out as being something that you would apply the chain rule to. The other one that I have in mind is d dx of cosine of 2x, something like this. Seems very straightforward. We could use the double angle formula, but then that would require a product rule. But using the chain rule here is necessary if we're going to take the derivative of this expression as it is. So the outside function, so that means I'll let, I'm going to let f of x equal cosine of x. That means f prime of x is equal to negative sine of x. I'm running out of board here. Negative sine of x. And we'll let g of x equal 2x, so that means g prime of x equals 2. So d dx of cosine of 2x equals f prime of g of x times g prime of x. And so now I'm going to start plugging in my information that I have. This is going to be f prime, g of x is 2x, so that's 2x, times g prime of x is 2, so times 2, which then equals f prime is negative sine of x. I will replace the x in this negative sine of x with 2x, so that's negative sine of 2x times 2. Again, this is an expression, sine of 2x, and then that whole expression is times 2. So it may be necessary to indicate to the reader that this entire expression is being multiplied by 2. One way that we can avoid this confusion is by bringing the 2 to the front. So that's negative 2 times sine of 2x. And so that's an alternate form to write it so that it's clear to the reader that 2 is being multiplied by the expression sine of 2x.